The AmurAct electric valve actuation system for purposes of demonstration, a demonstration valve, the AmurAct actuation system itself, and I have a signal generator here. The purpose of the actuator is to emulate the capabilities of a pneumatic actuated system in that you have to have fast speed of stroke, you need to have the strength and or force to be able to get good tight shutoff and be able to get good speed of unction. You've got a linkage system here which, using this mechanical advantage, allows us to get up to 800 inch-pounds of force on the plug into the seat area. Simulate an increased signal, then the valve is going to take that instruction, it's going to translate that into a demand to open the valve, and as you can see, that as the linkage raises, the plug is coming up off the seat. I'll go a little further. Now I'm going down, I'm closing it. If I close it further, you can see further how the linkage operates. Once it gets down into the fully closed or locked position, it is virtually impossible to upset that or open it accidentally. Now, with the electric motor on the back side connected to the linkage on the front, the motor will operate on 110 or 220 or 24 volt AC or DC. So all in all, you have the flexibility of the system to be able to allow you to do whatever you need to do for the actuation. Now I'm going to increase it, I'm going to open the valve up now, so that you can see that we can get full stroke in approximately 10 seconds, which emulates that of a pneumatic actuated valve. So once we have the valve open, and it's in its fully open condition, I can now take and simulate a fail closed situation without using springs for feedback. So if I kill the signal that way, it now says something is wrong, I've lost my power or I've lost my signal, and I'm now going to close since I've given it a dip switch instruction to fail-safe closed. And it will go fully closed without the use of springs. What I'm using is 4 1-farad capacitors, which are fully charged and ready to go into action after 30 seconds of initial power up of the system. So again, I can turn it back on again. The signal will go back to where it was before the failure. And in this case, it will now go back up to an open condition. And now, based on your varying input signal, your control signal, it will then start to track that set point and move based on the demand, based on the load demand of the loop, and maintain proper flow or pressure or temperature. The main point that this accomplishes is it saves the cost of producing air, so that for an equivalent size control valve of this size here, or 2-inch or 3-inch, it might cost up to approximately $800 a year for air, whereas with the electric system, it'll cost about $10 a year, so the initial savings is significant, as well as the savings of being able to run a pair of wires as opposed to an airline, which typically will leak anyhow right from the very beginning. So all in all, you've got cost savings, functionality has not been compromised, and flexibility is optimized.